Hey guys, this is awkward, but we're gonna go with it. So we're gonna do our Beer's Law lab. All that you really need is some test tubes and your stock solution. This is 1 molar copper sulfate, and then you will also need your SpectraViz, which is, I've got one right here. Okay, so the SpectraViz, I won't turn it over, but is really cool. There's only one SpectraViz. There are different colorimeters. I'll show you those, and each of them is hooked up to a LabQuest. Alright, and now in each SpectraViz, this will actually hold our samples. This is called a Cuvette. Notice that on this side there's the it's got grooves on it, and this is where you hold it, and then notice that there's a smooth side. Smooth side is where the light goes through, and you never touch the smooth sides. You only touch the rough sides. So I'm going to go ahead and place that back into the sample container and show you how a serial dilution works. So what we got here is we have a 5 milliliter pipette, and we've got our plunger right here. So there's two things to basically do. There's to roll it. We'll draw it up, okay? And now to get it out, you really don't want to push this one down. You want to push this little button right here with your thumb. So both of them are operated with your thumb, and you can transfer pretty well. Now on this pipette, there's one line. That one line represents 5 milliliters. Okay, so that's how that works. As you can see right here, I've already prepared my 5 milliliters of water in here. They don't look like the same volumes, but that's because the test tubes are different sizes. So they're okay. They're all 5 milliliters. In this one, I'm going to put my stock solution, and I'm going to do my serial dilutions. Don't really care about volume of this stock solution. We're just going to draw from it. So this is essentially the concept of Beer's Law. Let me go ahead and stir this one up. So on your left, I have a more concentrated solution, and on your right, I have a less concentrated solution. Now it may be difficult to tell the difference here, especially with my maroon background, but we should be able to check it out. So here's my original on the left and my new one on the right. So hopefully you can see that. And all I'm doing is taking 5 milliliters of the previous one, drawing it out, and then putting it and putting that 5 milliliters into the 5 milliliters of distilled water. Therefore, I have 10 milliliters. I stir that up, and then I take another 5 milliliters out and move on to the next one. So eventually what I'm doing is I'm cutting the concentration by half, right? Okay, so I started with 1 molar here. This one is, and this one is. Very good. All right. So a very great thing about serial dilutions is that you can start with something that's pretty concentrated, and you keep cutting it by half or by tenths. That's actually the real way we're supposed to do it. So if you had 10 milliliters of water in your test tube, and then you took 1 milliliter out each time, that would be cutting it by tenths. But here we were cutting it by halves. So you can still, as you see, you get a much less concentrated sample when you get it to the end. So if we cut them by tenths, after 5 test tubes, you've got a pretty dilute solution, and so that's pretty great. So as you can see, Beer's Law is about the concentration and the absorbance of light. So we are actually going to measure the real absorbance right here. So this one will absorb more light, and this one will absorb less light. Okay, my absorb. Okay, so you'll have to check the pre-lab and all that background information to understand that. Okie dokie. So we are done with our serial dilutions. Let's move on to the next step. This is how you will calibrate the SpectraViz in case you are working on it. So you will take the stylus and tap on the red section right here. Make sure you're on the section. Your mode is set to full spectrum at the moment. And you tap on here, you hit calibrate. It will say taking dark sample for just a minute, and then it will wait for 90 seconds for the lamp to warm up. Now that it says that it has finished the calibration, it says to place a blank cuvette in this device. Now what I mean by blank is not that it is empty, okay? I mean that it is full of water, okay? Because we're going to weed out all that light that's caught by water, even though there shouldn't be any. So we will go and hit finish calibration, and it will work on, and it will think for a second, and then it should be okay. Alright, once that's done, it said sample time is 74 milliseconds, which is good, and it should still read that. Okay, once we've calibrated, I was telling you that you should be on the full spectrum right here. Well, now you're going to change the mode, and we want to change the mode to events with entry. Now hopefully you can see this. It says concentration as the name, and then units as capital M, or molarity, right? That is what we're going to do. That is for our x-axis, okay? So what we are going to do, since it's an event with entry, every time we have an event or a sample, we will plug in our value of our concentration, and it will plot our graph all nice and neat for us. So it'll be nice. So right now, what I did is I jumped ahead of you guys, and I put in my cuvette of my stock solution. So I just took a normal pipette, and I added my stock solution to this from the test tube, and put it about 3/4 full. Now I will place it into the SpectraViz with the arrow pointing that way, and the wavelength was not all correct. The wavelength was saying something like 300 or something, whatever. So if you will notice on your lab, you've got this color wheel right here. Since we are reading blue, we want the wavelength to be orange. We want it to absorb orange, because there's no, we're measuring how much orange is absorbed. That's the absorbance. So we want a wavelength somewhere around here. So I just went ahead and estimated 600. So I typed in 600 right here. I went over to the red screen and I said change wavelength, and I typed in 600, and it will approximate 600 for me. So that's how that works. For the colorimeter, it's a little different. You only have 4 separate options to pick. To calibrate it, obviously you push the cal button with the water in there. The light will blink for a little while, and then it will go, and then it will turn off. That means it's calibrated. That's the easiest way to do it. And then you just have to change the absorbance using this. Now make sure that you let it sit for a while, and it will change itself. So as you can tell, as I change the wavelength, the absorbance changes as well. Okay, because it's absorbing, and it's looking for a different wavelength of light. I hope that makes sense. So coming back to it, we have our pure blue solution. It makes sense that the absorbance is close to 1. If it's over 1, that means that something's wrong. It needs to be close to 1 because it is absorbing all of the orange light. Okay, so we will now go ahead and record this So we'll hit play, and then are going to not hit stop in between measurements. Never hit stop in between measurements on this one. You're going to hit keep, okay? And then for keep, I'm going to say 1 molar, okay? It's exactly 1 molar, so we'll hit OK, and then there's my point. It just takes that y-axis point for me and records it. We made that first point, and now it's time to run the rest of our samples. So I conveniently poured them all out into our cuvettes, and they come with nice little caps, which are nice. So it's easier if you just prepare them all just like this, and then that way you can just switch samples out and place them in and take your reading right away. So it's not that bad. So once that's done, I put it in there, I give it a second, and now I hit keep, and now my concentration is 0.5. Okay? Okay, look, it decreased. Oh, look, and it was about 0.475. Oh, well, that's about half. That's a good idea. That's a good thing. So I put in the next one, and we're going to read it now. And I'll spare you the minutia, but I'll keep on going. So that is it for the LabQuest. The Colorimeter is essentially the same thing. The only difference is that you don't just type in the wavelength. All you have to do is move the wavelength instead. You still have to let it warm up, and you still have to calibrate it, but the calibration is a simple push of the button. All you have to do is lift the lid right here, and as you can see, there's still an arrow right here. That's where the light is coming from, so you want that arrow to be, I grabbed it the wrong way. You want that arrow to be facing the smooth sides. Alright, that should be it, and I hope you all have a great day.